Thermal energy, phase changes and whatnot. This is a phase change diagram. As a solid goes to a liquid to a gas, it is gaining energy. As a gas goes to a liquid to a solid, it's losing energy. The molecule structure in a solid is connected. The bonds between the molecules are very strong and the molecules are tightly packed. As heat is added to the solid, the molecules start to vibrate, and with more heat, the faster they vibrate. But the molecules don't break apart from each other due to their strong bond. In a liquid structure, the bonds between the molecules are not as strong as the bonds in a solid structure. The molecules take the shape as the container it is in. As the heat applied to the liquid increases, the molecules will separate further apart. At this point, the bonds between the molecules are broken and they move freely. This is called a gas. To measure how much heat is needed to melt an object like a solid, you can use this equation. Heat is equal to mass times latent heat of fusion. The latent heat of fusion for water is 80 kilocalories per kilogram. To measure how much heat you need to boil an object, use this equation. Heat is equal to latent heat of vaporization. The latent heat of vaporization of water is 540 kilocalories per kilogram. Thermal energy is measured in calories or kilocalories. A calorie is the amount of heat needed to raise 1 gram of pure water 1 Celsius degree in temperature. 1 calorie, cal, is equal to 4.2 joules. Joules is a unit to measure heat. A kilocalorie is the amount of heat needed to raise 1 kilogram of pure water by 1 Celsius degree in temperature. 1,000 calories is equal to 1 kilocalorie. 1 kilocalorie, kcal, is equal to 4,186.8 joules. Specific heat capacity. Specific heat capacity is the amount of heat necessary to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. Remember that different materials have different specific heat capacities. Here's a table listing different substances, different specific heat capacities, such as aluminum, iron/steel, copper, brass, zinc, and so on. Specific heat depends on 3 factors: the mass and the heat that is being applied to, and temperature change.